Hello, Gen Chem students. Since we were already talking about acids and bases, I thought that I might as well provide a little more context and history to this because we're only dealing with one theory of acidity and there's actually a few others. Way back in ancient times, we had the word acetum, which means sharp. And for a long time, we defined what was an acid by what tasted sharp. Similarly, we defined bases by the fact that they would essentially etch base metals. This was all we knew. It was a description of how things behaved. We had no idea of the chemical underpinnings. Finally, somewhere around the Enlightenment, there was a chemist called Arrhenius who figured out that the things we knew as acids at the time, when you put them in water, generated H+. That should sound a little familiar. Similarly, bases were compounds that generated OH- when you put them in water. So now we had a higher degree of understanding of how acids and bases worked, but this was still more of an observation or a natural law rather than a real theory of why acids were acids and why bases were bases. That came a little later with the Bronsted-Lowry definition of acids and bases. They discovered contemporarily, so it was independently discovered, but they did it at the same time, so we give them both credit. They were the ones that figured out that acids specifically donated protons and bases were the ones that accepted them. This added a little more complexity, and it also gave us predictive power. If we knew the formula or a little bit of the molecular structure of something, we could predict now whether it was going to act like an acid or a base. This gave us a lot more power. But even this wasn't quite enough to let us fully describe all of the types of acid-base-like interactions we observe as chemists. And this is where Gilbert Lewis came in, who was brilliant, one of the very best chemists who ever lived. He gave us the Lewis theory of acidity and basicity. And his definition of a base is a compound that donates electron density, whereas an acid is one that accepts electron density. And this is kind of a flip of what we've been talking about so far. We've been defining the acid as the donor and the base as the acceptor. Lewis is the opposite of that, but because of this added layer of complexity of understanding, this is actually explaining those previous theories of acidity. If you take a look at, an acid donating a proton to a molecule of water, it's the lone pair on that water molecule that's accepting that proton. So you can think about it in Lewis acidity and basicity as the water acting as a Lewis base, donating its electron density to that proton and taking it away from that acid. The proton itself is acting as the Lewis acid in that case by accepting the electron density of the oxygen lone pair. So now that we have Lewis acidity and basicity, we no longer need protons. We can describe the Lewis acid character of a carbon atom in a structure, or some other type of atom like a metal or other things like that. And this opens up a huge new world of explaining how chemistry works. That type of progression from simple natural laws derived from observation to basic theory to truly fundamental theory is the goal of all of our scientific research. I hope that satisfied a little bit of your curiosity. If you have other questions, please feel free to get in touch. Drop by my office hours. Otherwise, have fun doing your Chapter 15 homework, and I'll see you guys in class.